This is video A of counting principles, permutations, and combinations. We'll first discuss the fundamental counting principle, define permutations, and find the formula for combinations. First off, the fundamental counting principle. This is the number of ways a series of successive events can occur is found by multiplying the number of ways in which each event can occur. Okay, so we are going to be multiplying options, and we have a couple of examples. For example 1, a multiple choice pre-calculus final has 46 questions with 5 answer choices for each question. If you were to answer each question, how many ways could you complete the test? Well, for the first question, we have 5 options. The second question, we have another 5. The third, and another 5, and so on. And so we can keep on multiplying out until we have 46 multiples of 5, because we have 46 questions and 5 choices for each question. We can multiply that out, and that is approximately 1.42 times 10 to the 32nd. That's huge. That's how many possible ways you can answer the pre-calculus final. Now, for example number 2, how many Alaska license plates are possible if no letter or digits are excluded? So there are 6 options on an Alaskan license plate. The first 3 are alphabetical choices. The second 3 are numerical choices from 0 to 9. For each of these alphabet places, we have 26 options because there are 26 letters of the alphabet. For our first number, our first letter, we have 26 options. Since no other letter is eliminated, we have another 26 choices for our second. For our third letter, since no letters were eliminated, we have 26 choices. As for our single-digit numbers from 0 to 9, that really expands and gives us an option of 10 numbers, not 9, because we're going to count 0 as this number 2. We have 10 options for our first digit. We have another 10 since no number was omitted, and we have another 10. If we were to multiply this out, we have a whopping 17,576,000 possibilities for our Alaskan license plates. I'd like for you to answer the Got It question number 3. You have decided to go to the movies this weekend and have chosen 3 pairs of jeans, 4 shirts, and 2 pairs of shoes that you would like to wear. How many different outfits can you come up with? Using the fundamental counting principle, I'd like for you to solve that to find the answer. Once you're completed with the Got It question, let's move on to the definition of a permutation. The number of possible permutations of R items are taken from N items is called a permutation. Order is very important, and rearrangement of the elements will create a new set or a new situation. In a permutation, no item is used more than once, and order makes a significant difference. We have a notation called N, P, R, and this reads the number of permutations of N things taken R at a time. This is defined by N factorial divided by N minus R factorial. So let's take a little example here. Leaders of 8 countries have a joint photo taken at a summit meeting. And how many ways can they line up for the photo? Well, because all permutation problems are also a fundamental counting problem, they can be solved using the permutation definition or using the fundamental counting principle. Let's think about our 8 different leaders here. We 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, here we go. And we have to take a look at our options. We have 8 options for our first position, 7 for our next, 6, and we can continue down. And this will end up becoming our product. This is a fundamental counting example. It also eliminates one person when we go to the next, so it's an also example of a permutation. If we are to multiply this out, this is also 8 factorial, and this is 40,320 ways. So let's say you order a triple scoop cone at Baskin-Robbins, which has 31 flavors. How many different cones could you order if you have 3 different flavors? So taking a look at an ice cream cone with 3 different scoops, we are also considering that you cannot, a cone with 1 flavor on the bottom is also the same as it being on the top. So we're just looking at the combinations and options of that. So we will go ahead and define what we know. We have a total of 31 flavors, so n equals 31. And we are trying to find the combination of our items, and our R is 3. So using our notation of the permutation, we can go ahead and say that we have 31 factorial over 31 minus 3 factorial, which is equal to 31 factorial over 28 factorial. And if we go ahead and extract the 31, 30, and 29 out from the numerator, we can see that we cancel out, and we have the multiple of 31 times 30 times 29, which is equal to 4,495 different ways. I'd like for you to continue and answer the Got It question number 6, and then we'll move on to the next video.